Awesome. So, guys, what we're going to be looking at today is carbon. Carbon is what makes up everything in the entire universe, from our backbones to our fingers to everything you eat, anything that's organic. And we're going to get into what all that means today. So one of the first things I want to do is I want you guys to watch this video real quick. I think it's really, really good. So check this out.
A class of compounds that contain carbon. And carbon is this sexy little minx in the periodic table that's, disinterested in monogamy. Jezebel. Bit of a tramp. Pussy. When I say carbon is small, I mean that it's actually, as an atom, it's a relatively small atom. It has 6 protons and 6 neutrons for a total atomic weight of 12. Because of that, carbon doesn't take up a lot of space. And so carbon can form itself into weird rings and sheets and spirals and double and even triple bonds. It could do all sorts of things that could never be accomplished by more bulky atoms. It's basically, your atomic equivalent of an Olympic gymnast. It can only do all of those wonderful, beautiful, elegant things because it's kind of tiny. I also said that carbon is kind, and that's an interesting sort of thing to say about an atom. It's not like some other elements that are just desperately trying to do anything they can to fill up their electron orbitals. No, carbon knows what it's like to be alone, and so it's not all, please, I'll do anything for your electrons, needy like fluorine or chlorine or sodium is. Elements like chlorine, if you breathe them in, they literally tear up your insides, and sodium is insane. If you put it in water, it explodes. Carbon though, meh. It wants more electrons, but it's not gonna kill to get them. It makes and breaks bonds like a 13-year-old mall rat, and it doesn't even hold a grudge. Carbon is also, as I mentioned before, a bit of a tramp because it needs 4 extra electrons, and so it'll bond with pretty much whoever happens to be nearby. And also because it needs 4 electrons, it'll bond with 2 or 3 or even 4 of those things at the same time. And carbon is willing and interested to bond with lots of different molecules, like hydrogen, oxygen, phosphorus, nitrogen, or to other molecules of carbon. It can do this in infinite configurations, allowing it to be the core atom of complicated structures that make living things like ourselves. Because carbon is this perfect mix of small, kind, and a little bit trampy, life is entirely based on this element. Carbon is the foundation of biology. It's so fundamental that scientists have a pretty difficult time even conceiving of life that isn't based on carbon.
Okay, great. So that video, I think, is a good little intro into what we're going to be learning today. So we'll start right here. So carbon, really, right? When we look at carbon on the periodic table, it looks like this. All right, and as we know, right, that's our atomic number, which gives us the number of protons, which happens to equal the number of electrons, right? So we can say it has 6 electrons, okay? But the really big difference is going to be the fact that it can only actually use 4 of these electrons to make bonds. And we're going to be going into what this exactly means today, but the electrons that an atom has that are actually able to make bonds, we call these valence electrons. Okay. Awesome. So valence electrons, they're found in what's called the very outer orbital, which is outside the nucleus. Remember, when we were talking about electrons, right? If we had our nucleus here, right? And our nucleus was made up of protons and neutrons, right? Remember we said that it was the electrons, right? They were all outside, right? This nucleus. Well, what happens is some are closer to the inside and make up one orbital, and others are more on the outside and they make another orbital. Only the electrons on the very outside, these guys, are actually able to engage in making chemical bonds, okay? Those that are inside, they can't, all right? They're not able to do that. So these on the outside are what are called the valence electrons. And essentially that's what you're seeing right here, okay? Only 1, 2, 3, 4 of carbon's electrons are on the outside, all right? And because of this, right, it only has 4 valence electrons, and it can only make 4 bonds. Okay, that's the long story short with this carbon. But this is the picture that you guys really want to know, because those that are on the inside, all right, this guy and this guy, right, they're not able to make bonds. So as far as electrons go, they are pretty useless overall, right? Okay, so now that we have a general understanding of what carbon is, I want to go back to this. Now you guys should remember what this is, right? And I just briefly went over it. So our atomic mass, it's down here, right? So that's our 12.011 number. And remember that this number is equivalent to the protons plus the neutrons, okay? What we have over here is, what is our atomic number? Well, the atomic number we went over, right? It's this thing right here. This is number 6, right? And that is the protons, which equals the electrons. All right? And as we just said there, right? That's how many protons we have is 6, and that's how many electrons we have. Okay? So that's a quick review of all of that. I hope you remember most of it, considering we just had a quiz on it, and it will be on your exam coming up in mid to late October. So the properties of carbon, right? First and foremost, what I want you guys to know is that its organic chemistry Okay, organic chemistry is the study of carbon and carbon-containing compounds. So anything organic is basically anything that's been alive, right? So you're organic, your food is organic, all of that stuff. It's something that's not processed or factory made, okay? Carbon is able to make 4 single bonds, right? Because it has 4 valence electrons. It's able to make 2 double bonds, and we'll get into what that means in a minute. Or it's able to make 1 triple bond. Okay, what's important to know is that double bonds, instead of sharing just 1 electron, you're sharing 2 electrons. And in a triple bond, you're actually sharing 3 electrons. Cool. All right, so carbon's able to bind to a lot of other atoms. That's why carbon is so useful in so everything, like you heard in that video, right? So carbon's able to specifically bind, these are the important ones you should know. It's able to bind to other atoms of carbon and hydrogen and nitrogen. Okay, those are the 3 that we're going to focus on. But again, it can literally bind to anything, and it can make multiple bonds to these things. And that's what makes carbon really unique overall. What can happen though, right? So when a carbon binds to a carbon, which binds to a carbon, and all of a sudden you have this really long chain of carbon, right? It creates these large complex structures known as macromolecules. And we're bringing up the name now. I definitely think you need to remember this definition, but we're going to be going into what exactly a macromolecule is in the next slide. Just know that at its very core, it is strings and strings and strings and strings and strings of very long carbon chains. Okay? But getting back to this idea of single bonds, double bonds, and triple bonds, I'm going to show you exactly how they're drawn. Okay? So a single bond, right, you're going to see carbon in the center, and what you do is you draw its atomic symbol, which is C. And then to show a single bond, you just draw a line. And we can connect it to a hydrogen there, a hydrogen there, a hydrogen there, and another one. And remember, because it has 4 valence electrons, it can make 4 different single bonds. Okay? And so what one of these bonds is really showing, okay, a bond right here, when you see this, this is 2 electrons within that bond. So there's 2 electrons being shared there, 2 there, 2 there, 2 there. So there's a total of 8 electrons being shared. 4 electrons are being shared by carbon. right? And then the other 4 electrons are being shared by the hydrogen. Okay, so that's just common nomenclature. You guys are going to have to draw these, and it's very important that you know what these symbols actually mean. Okay, now to draw a double bond, okay, so if we show our double bond, right? The only difference, so we can do this between a carbon and an oxygen, right? So C is the atomic symbol for carbon, O is the atomic symbol for oxygen, right? And what we do to show a double bond, right? Instead of just drawing one line, you're going to draw 2 lines, okay? And once again, what this is showing is that not just 2 electrons are being shared, but 4 electrons are being shared. Okay? And sorry, I know that green is not the best. It says are being shared. Okay? 2 of which from carbon and 2 from oxygen. Okay? So that's exactly what's going on there. So overall, 4 total are being shared, 2 from carbon and 2 from oxygen, and that's within a double bond. Now, if we want to go on to what a triple bond is, and excuse me for running so far down, I got a little carried away there. So we're going to try and quarter that off. Okay. But if we're focusing on a triple bond, right, what a triple bond is going to look like is we're going to have our carbon again. Okay, and what the carbon is able to do is that you can actually have it in a triple bond by showing 3 lines. Okay, and you could do something like that with nitrogen. But that's what you're going to see is that there's 3 bonds here. And, you know, once again, to reiterate, when you see 3 bonds, this means that you have 6 electrons being shared, right, within that bond itself. And it's 3 electrons from carbon and 3 from nitrogen there. Okay, so that's what's going on. And again, it's very important that you guys remember all of that. So I want to do a quick check. I know it's going to be a little different because you guys are not able to do this on your own at home. So I'm going to show you how to do it. But the real big thing is look at how many lines you have, right? So here, if I asked you how many bonds there were overall, you would say there's 1 bond, 2 bonds, 3 bonds, and 4 bonds. Okay, so we have 4 bonds. And each is 1 line, right? So we're what carbon is doing here is sharing 1 electron with each hydrogen. So we have 4 single bonds. You don't see any double lines and you don't see any triple lines. Okay, so all we have here are 4 single bonds. Now, as we move over here to the middle, right? Again, let's get an overall count. So we have 1 bond, 2 bonds, we have 3 bonds. Okay, there are 2 bonds that are single lined. Okay. Right there, right? And there is 1 bond that is a triple bond, right? There's 0 bonds that are double. There's no with just double lines, right? All right, last but not least, this is a real fun one, huh? We have everything here. So let's quickly count. So we have 1 bond, 2 bonds, 3 bonds, 4 bonds, 5 bonds, 6 bonds, 7 bonds, 8 bonds. We have 9 overall bonds. Right? Now, how many of these just have 1 line? We have 1, 2, 3, 4, 5, 6 single bonds, right? Okay. How many double bonds? We got 1 double bond. Oh, did I miss one? Oh, I did. Do you see that? We don't just have 6. It's 7. Let's call that in the right color. 7 single bonds. My fault. You guys probably caught that at home. What I do want to go into next though, right? So we have that one double bond, and then we have this second double bond. So we have 2 double bonds. And we have 0 triple bonds. Now, a quick check, right? What should happen is that these numbers should add up to that number, okay? So the indiv bonds should add up to total bonds, okay? And we have that here because 7 plus 2 plus 0, that equals 9, which is the number that we have up top there. Okay, so we did that right, and that's how you can always double check. Lastly, I told you guys we'd be getting back to this macromolecules idea, and this is really just an intro to what we're going to be doing in class tomorrow. But what macromolecules are, they're these long complex chains of carbon, okay? And what macromolecule actually means is giant molecule, because that's exactly what it is, believe it or not. Okay, and what it's made of, right, it has these small units called monomers. Okay, monomers are individual hope you can see that there, right? They're individual units. Okay, and what these guys do is they join together to make one large unit called a polymer. Okay, and it's these polymers that make up macromolecules. So we have monomers, which are really small units. Okay, these monomers fuse together to make polymers, and it's a bunch of polymers which become a macromolecule. So a macromolecule is a bunch of polymers. You betcha. All right, and this fusing process that I just talked about, when the monomers fuse to become a polymer, we call this process polymerization. Polymerization, okay? And that should be pretty self-explanatory, okay? You're making monomers into polymers through polymerization. And you can see that going on right here in this photo, okay? You have these small pieces. We're gonna get in future lessons to what these actual smaller pieces are, but you can see them getting fused together, right? These guys are all coming together, and they're making this polymer down here, okay? And the really important thing is that why these macromolecules are so important is that they are found in all living things, okay? From bacteria that might be alive to humans to plants, anything that is alive will have these macromolecules, okay? They are essential for life. And we're going to get into exactly what these are in next class, but I wanted to give you a brief introduction to this. Lastly, what you have here, I'm not going to fill this out for you, but these are all of your key terms from this lecture I just gave. What you should do right now is a quick check to see if you know what they mean. If you don't, go look in your notes and definitely define them and fill them out. So this can be a quick look for you guys. I really hope you enjoyed this. We're going to be talking about this in class for the next 2 weeks. So on the boat of carbon we are, and I will see all of you guys tomorrow.